Hello everybody, this is Holden and I'm back for the 11th R-Help video. So today I'll be going over 3 important sections listed below. Let's jump right into it and go with sample variance first. So to do this I'm going to create some sets. I'll create set 1, these are just arbitrary numbers, and set 2. Make sure you don't forget the C, it just tells R that it's a vector. Okay, so now we have our 2 sets. Now let's calculate sample variance. So to do this we do ST set 1 squared. And this is the sample variance for our first set. We could do the exact same for set 2. Let's find sample standard deviation now. And this is the square root of the sample variance, as we've learned earlier. So it's consistent variance, sample standard deviation. Now, the last part of this section, the standard error. So this is actually the standard error of the differences of sample means. So we're going to do square root ST set 1 squared divided by n, which is 5 in this circumstance. 1, 2, 3, 4, 5. We have 5 numbers in the set. And we have 5 numbers in the second set as well, as you can see here. And that is the standard error of the difference of sample means. Perfect. Now that we have those, we can move into the test statistic. So the t.test function gives you the test statistic, but you need to know how to conceptually calculate it, so we'll go over it right now. It's y bar minus y bar over the standard error. And the standard error is from here. So anytime you want to find the test statistic, you do it in this manner. If you're assuming that the true mean difference is 0, like it is on the homework, so you will not have to account for a non-zero, this formula. Now let's go into using the t-test function, which makes this a lot more efficient. So to do this, we do t-test neighborhood 1, neighborhood 2. These are some sets from the homework. And let's go through some of the things that this is telling us. It's telling us t, it's giving us a p-value, it's giving us a 95% confidence interval, and a sample at the mean of y and x. However, sometimes there's going to be increased complexity in what you're inputting into the t.test function. So I'll go over some of those right now. You could say paired equals true, alternative equals greater, and it could also be less, or comp dot level equals 0.99, for example. And these things would change how R does it, and now it's giving us a 99% confidence interval. Instead of the 95 default, we could also change this to 90. And the whole reason I'm showing you this is so you can keep in mind that on the homework you might need to use paired equals true, or alternative equals greater or less. And again, if you forget what alternatives there are, you can do t.test, and then it will show them to you right here. Two-sided, less, greater, and it also tells you the other options. So mean equals paired, variance equals confidence level. Okay, thank you for watching, everybody, and please come to office hours or email me if you have any questions, and I'd be happy to help you.